Hello students! So this is part 2 or a continuation of that last video of solving quadratic equations by factoring. In this video, again, we're just going to continue and we're going to look at a few examples. So let's say that we're looking at this example here. So if we had to factor this or solve it by factoring, the first thing is making sure that the equation is set equal to 0. That one side of it is set equal to 0. So we've got that. Okay, we've got this equation where one side is set equal to 0. So that part we don't have to worry about. So since one side is set equal to 0, we need to factor the side that is opposite from the 0. We need to factor the expression that's on the opposite side of that 0. So if we factored that expression, we would wind up finding two factors of 64 that add to give you negative 16. So those two factors there are going to be negative 8 and negative 8. So they multiply to give you positive 64. They add to give you negative 16. So again, we factored this left side of the equation into these two factors here. Now, of course, when we do that, the right side of the equation is still equal to 0. So these two factors are going to be x minus 8 and x minus 8. So now that we've got these two factors, what we need to do is we need to use the zero product property. And that pretty much, or we use that property by setting each factor equal to 0. So once you have the two separate factors set equal to 0, you need to solve each equation without the parentheses. So if we solve this equation here, again we add 8 on both sides and we wind up getting that x equals 8. Same thing here. Usually, again, you would have possibly two different or unique answers. But again, in this case, x equals 8. And that is the only solution here. All right, so let's look at another example here. So with this example 2 here, notice how the equation is written. Remember, when we are asked to solve an equation by factoring, the first thing that you need to make sure is that the equation is set equal to 0 on one side. This equation is not set equal to 0 on one side. So, how are we supposed to factor it, Mr. Starkey, if the equation is not set equal to 0 on one side? Good question. Well, folks, let's rewrite this equation. Let's do some algebra. Let's move some of the terms around. So I'm going to move these two terms on the right side of the equation over to the left side of the equation. And you could move the term on the left side to the right side of the equation, but I'm going to move these things to the left side of the equation so that I can keep my my leading term positive. We wind up having x squared equals, x squared minus 4 equals 0. So now this expression or the equation is written where you have one side equal to 0. And so if we are going to solve this by factoring, looky there, y'all. It doesn't have 3 terms. Well, we've looked at a pattern sort of like this before. So this type of factoring is a difference of squares, right? Where it can be written in a form like this. Something squared minus something squared, right? So in this particular case, it is x that's being squared here, and it is 2 that's being squared here. 2 squared gives you 4, x squared, of course, gives you x squared. So remember that in this particular case, a equals x, b equals 2, and when we use the formula, we want to factor this difference of squares into the form a plus b times a minus b. Again, we have identified what A is and what B is. So when we write it out in this particular form, the difference of squares will be rewritten as x plus 2 and x minus 2. Now, of course, this is still an equation. We're just factoring the left side of this equation. This equation is still equal to 0. And now we're going to use the zero product property. And we're going to set each of these factors equal to 0 and solve. Okay, so when we solve this, we wind up getting, or when we subtract 2 from both sides of the equation on the left side, we wind up getting that x equals -2. And then on the equation on the right side, if we add 2 to both sides, we wind up getting that x equals +2. So here we have two distinctive or unique answers, x equals -2 and also x equals 2. Yes, we do have two separate answers here. So let's say we are looking at this example here, example 3. So again, the first thing we want to do when we're solving this by factoring is get it written so that the equation's equal to 0. So let's move around some terms. Let's use some inverse operations here. So we've got this equation here. It's equal to 0 now. Some of you are probably looking like, well, okay, now, Mr. Starkey, this equation here looks mighty complicated. It looks mighty. Got some big numbers in there, Mr. Starkey. So remember in one of the previous videos that I made about common factors or GCFs, we said that you should always check to see whether or not there are any common factors or greatest common factors. And in these three terms here, there is a greatest common factor. First off, each of these three numbers, the constants there, each of them is divisible or can be divided by 2. 2 is a common factor between all of them. But 2 is not the greatest common factor between them. The greatest common factor between those three numbers is 4. So when we factor out this GCF here, it's a 4. Let's look at what it will look like afterwards. So we have the GCF on the outside, and we are going to write what's left over when we factor out that GCF. What's left over should be x squared minus 11x and then plus 28. And remember, this is still an equation that's equal to 0. So, after we factor out that GCF, if that GCF, that greatest common factor, if it is a constant, remember folks, that a constant is a number that is written without a variable, a number that does not have a variable. So here, 4 is a constant. That GCF is a constant. So since it is a constant, we want to use the inverse operation of dividing to cancel out that GCF. So what are we saying? We're going to divide both sides of the equal sign by 4. Alright, so again, we divide both sides of the equation by 4. That cancels out the 4's on the left side. And 0 divided by 4. Here we are dividing by the number 4. Okay, we can divide 0 by a number. We're dividing 0 by 4 here. The result that we're going to get here is 0. Don't get that confused, guys. It would be different if 0 was at the bottom here. Then we'd be trying to divide by 0, and you cannot divide a number by 0. So, but you can take 0 and divide it by a number, like what we're doing here. All right, so what we get here is 0. And what's left over is the expression that was already there, x squared minus 11x plus 28. Now we really don't even need the parentheses. All right, so if we factor that expression, remember again, we're looking for two factors of 28, the factors of c that will add to b. So two factors of 28 that will add to negative 11. So these factors, as they're written right now, will only add to give you positive numbers. So again, that means we have to consider those same numbers with the opposite signs. So the only pair here that even remotely adds to 11 is this last pair. So if we switch the signs for that, that would be -4 and -7. That still multiply to give you positive 28, but then they'd add to give you -11. So if we use those two factors, the -4 and the -7, write out our two factors of this quadratic trinomial, it will be x minus 4 times x minus 7. Remember that this is still an equation, so it's still equal to 0. And so we need to use that zero product property and set each factor equal to 0 and then solve each equation. All right, so when we do that, we get x minus 4 equals 0 and x minus 7 equals 0. If we solve this equation on the left side, we wind up getting, or when we add 4 to both sides, we get that x equals 4. And then when we solve the second equation here, by adding 7 to both sides, we get the x equals 7. All right, and those are our two answers for this problem here. All right, so let's say we were looking at this next example, example 4 here, and we had to solve by factoring. When we look at this one, this equation is already set equal to 0 on one side, so we don't have to worry about that part. And some of you may be looking like, okay, that's not quadratic, Mr. Starkey. You're right, it's not quadratic. But if you notice here, there are some common factors here. And so remember, you should always check to see whether or not you can factor out a GCF, a greatest common factor. With these two terms, there is a greatest common factor here. For these two terms, both of them have a factor of 2, and they both have at least one x in common. And actually, I suggest actually factoring out negative 2 when you do this here, so that your leading term, or so that the leading term will wind up being positive after factoring out that GCF. Okay, so in some of the previous videos that I did on factoring out GCFs, just to kind of show visually, I wrote out those exponents for the variables. I wrote it out as repeated multiplication so that you can kind of visually see factoring out the GCF there. So for the number, I'm going to suggest that we factor out a negative 2. If we do that, then this winds up being -1 here. And if we factor out -2 from that second, sorry, not -1, but +1. Sorry about that, folks. And then if we factor out -2 from the 18, this winds up being -9 that's left over there. All right, so with the variables, again, with GCFs, not only do you need to consider the numbers or the constants, but you also need to consider the variables involved as well. So again, with the variables, there are an x in common between them. Okay, so when we factor out our GCF, which is, when we put it all together, the part that came out from the numbers and from the x, GCF is negative 2x. When we factor out that GCF, the way that it winds up looking, so we'll have the negative 2x on the outside of the parentheses, and we'll wind up having x squared left over, because again, if you factor out, or if you take away and factor out the GCF, you can see what's left over here. 1 is the number left over, so that's the coefficient, and there's 2x's left over. And so that's 1x squared left over from the first term. From the second term, the only thing that's left over when we take out the GCF is negative 9. Alright, so when we do that, this is what we get. Remember, this is still an equation. It's still equal to 0. So we have factored out that GCF here, and we can see that, or we should kind of recognize that even though we factored out the GCF, it is still possible to factor this particular factor a little bit further. So whenever it is possible to factor completely, and that means to keep on factoring even more, then we need to do so when it's possible. So we can see here that this particular that this part that we can factor further is a difference of squares, and we need to factor that into the form that difference of squares are factored into. So it's a difference of squares because it can be written in this form, a squared minus b squared. And so in this form, we can identify what a is, that's x, and we can identify what b is, and that's 3, because 3 squared is what gives us 9, and of course x squared is what gives us x. So we know what a is and we know what b is. A is x, b is 3. Alright, and so we need to factor it into that form, a plus b times a minus b. So when we do that, and if we actually bring down everything, because we still got the same equation, so we still got the GCF negative 2x that we factored out, but now we're factoring this this difference of squares into 2 different terms. So we've got negative 2x that was already there, and let's break this down into this form, a plus b times a minus b. And so that is going to be x plus 3 times x minus 3. Okay, so now, and don't forget that this is still an equation and it's equal to 0. So now what we need to do is we need to use the zero product property, and we need to set each factor equal to 0. Now, I know you're thinking here, I know you're looking, okay, Mr. Starkey, in all the other ones, we only had 2 factors. But in this one, we've got 3 factors. You're right. We do have 3 factors. We've got negative 2x, we've got x plus 3, and we got x minus 3. So still, we need to set each factor. So we need to set all 3 of these factors equal to 0 and solve. So when we set each equation here equal to 0, and then we solve without the parentheses, solve each equation. So for this first equation with the negative 2x, to get x by itself, we have to divide by negative 2. When we do that, we wind up getting that x equals 0. Remember, we can take 0 and divide it by a number. 0 divided by negative 2. Think of it like this. If you've got $0, you can split it 2 ways. I'm going to give you half of 0. Half of 0 just so happens to be nothing. Yeah, if I've got $0 and I want to split it between two people, guess what? Two people are going to get nothing. Pick that, nothing. Anyway, so that is x equals 0. For the second equation, we got x plus 3. To solve, we have to subtract 3 from both sides of the equation. And when we do that, we get x equals negative 3. For the third equation, to solve that, x minus 3 equals 0. We have to add 3 to both sides of the equal sign. And so when we do that, we get x equals 3. Here, we happen to have 3 distinct answers. So this equation here was not quadratic. It was actually a cubic equation, but there was a quadratic factor involved in this one, and that quadratic factor was x squared minus 9, and that was a difference of squares. Anyway, and so those three values are the answer for this example. We're going to look at one more example. So let's look at this example here where we're asked to solve by factoring. Example 5. So when we look at this here, we clearly see that we're not going to be able to factor this one, not until we get the equation set equal to 0. Oops, and that's supposed to be 15x. Glad I saw that. We're going to move these terms all to the same side of the equal sign and get it so that one side of the equal sign, or one side of the equation, is equal to 0. That leaves us with 0 on the right side, and on the left side we've got negative 6x squared plus 28x plus 48 equals 0 now. Alright, so when we look at this, we should sort of recognize what to do. Even though that sort of looks a little complicated, you should recognize that there are common factors between these terms in this expression on the left side. So remember that the first thing you want to check out once you've got the equation set equal to 0 is you want to check to see if you can actually factor out any GCFs. So when we look at these three terms here, what they do have in common is a 2. All three of them have a 2 in common as a factor. And I'm going to factor out negative 2. And that way when I factor out negative 2, I'm going to have a positive leading term that's left over. From the first term, what's left over, or at least the number part of it that's left over, is 3, positive 3. Okay, there are 2 x's there. All right, and actually, there's really not a need to do anything with the x's, because all three terms do not have x's. So we're only dealing with numbers or numeric or constants that are a part of the GCF here. Here our GCF is negative 2. So let's factor that out here. So we got the negative 2 on the outside, and what's left over from that first term is 3, and it still has all of the x's. Okay, and then from that second term, what's left over when we factor out that negative 2 is the negative 14, or minus 14, and we still have the variable there, x. And then from the third term, or that last term, what's left over when we factor out that negative 2 is negative 24, or minus 24. And guys, remember that this is still an equation, and it is still equal to 0. And so we factored out that GCF. And so notice that again, our GCF is a constant, and that means that it's written without a variable. So since it is just a number without a variable, what we're going to do is we're going to divide by that GCF. We're going to get that GCF to cancel out. So again, guys, we're going to divide both sides of the equation by that GCF. So we're dividing by negative 2, dividing by negative 2. When we do that, again, this cancels out. The negative 2's on the left side we're left with 3x squared minus 14x minus 24 equals 0. Alright, so what we can see here is that it is possible to factor this, or maybe you don't recognize that it's possible to factor this, but one of the videos that I made for you before was factoring quadratic trinomials using factoring by grouping. And so with this, remember that there are certain steps that we take when we're factoring by grouping. First, what we want to do is multiply the a times the c. So remember, first we can identify a, b, and c because this quadratic is in standard form, which means it's in the form ax squared plus bx plus c. Okay, and it's an equation, and this expression is of course equal to 0. But this expression on the left side of the equation is in standard form, and we can identify a as 3, b is negative 14, and c is negative 24. And so what we want to do is we want to multiply a times c. So a times c is negative 72. So that product of negative 72, we want to identify factors of that product. Identify factors of negative 72 that will also add to b. So we want to find factors of negative 72 that will add to negative 14. So we're looking for two factors of negative 72 that add to give you negative 14. And some of you may want to write out the factors of negative 72. I'm just going to write out the absolute value of these factors first without any signs. So we got 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. So we're looking for two factors here of negative 72 that will add to give you negative 14. First off, if we're doing factors of a negative number, remember that means that one of these factors has to be negative. So and if one of these numbers is negative and the other one is positive, that means that we're looking at the difference between these numbers. So when we look at the difference between these numbers, the difference between the first pair is 71. The difference between 2 and 36 is 34. The difference between 3 and 24 is 21. The difference between 4 and 18 is 14. So we can see here that these two numbers, 4 and 18, will give us a difference of 14. So the question is, which of those two numbers needs to be negative in order for it to add to negative 14? So the only way that that's going to work is if we do it as a negative 18. Positive 4 and negative 18. All right, so once we've got those two factors, what we need to do is we need to rewrite, or we need to use those two factors to rewrite or in other words, to replace the middle term, negative 14x. And so we'll replace the negative 14x using those two factors. So again, we're going to take those two factors and we're going to split the middle term. So when we rewrite this, it's going to look like this. 3x squared, and again we're going to replace that negative 14x with two terms that are using these two numbers, those two factors that we just now identified. So we're going to write it out as 4x, and That's using the 4, and we're going to use that negative 18 minus 18x. So when we do that, this is still equivalent. Now that this is written with 4 terms, now we can factor by grouping. So remember that with factoring by grouping, the first thing that you do, again, if you've got 4 terms, an expression with 4 terms that could be factored by grouping, is you want to group your terms. You group the first 2 terms together and you group the last 2 terms together using parentheses. Alright, so we've got our terms grouped with parentheses. The next thing we want to do in factoring by grouping, remember, is to factor out the GCF from both of those groups. For the first group here, the greatest common factor, well, okay, so 3 and 4, those 2 constants, those 2 numbers don't have any factors in common. But if we look at the variables, at the x's in each of those 2 terms here, in this first group, so we have, okay, the 3x squared and the 4x. Each one of those terms has at least one x. So there is a x that they have in common as the greatest common factor for that first group. For the second group, okay, they don't have any x's in common because the 24 does not even have any variables. So between the numbers, the constants, negative 18 and negative 24, the greatest common factor there is 6. However, guys, since both of these are negative and the other two terms were both positive, I'm going to factor out a negative from these 2 terms over here on the right side in this group. I'm going to factor out negative 6. Because again, I had mentioned in one of the previous videos that we did on factoring by grouping that when your signs are opposite for the 2 groups, like here you have a positive and a positive, here you got the opposite signs, negative and negative, right? It's the complete opposite sign. So when you have the opposite signs like that, then you definitely want to factor out a negative number for at least one of those GCFs, for at least one of those groups. So when we factor out an x from that 3x squared plus 4x, what's left over? What multiplied times x gives us 3x to the second power? So x times 3x will give us 3x to the second power. All right, and what multiplied times x will give us 4x? Okay, well, if we multiply x times 4, we get 4x. If we write out and factor out that GCF, negative 6, what's going to be left over when we factor out that negative 6? So negative 6 times what will give us negative 18? Okay, well, negative 6 times 3. Negative 6 times 3 will give us negative 18. And then there's still an x left over there. And then negative 6 times what will give us negative 24? Okay, well, negative 6 times positive 4 will give us negative 24. So what we should notice here, right at this place where we have factored out the GCFs, we should notice that we've got the same factor. We've got the same factor here, the 3x plus 4 from that first group, and we've got the same factor, 3x plus 4 from that second group. Having that same factor lets us know that we are on the right track. So, in the end, now that we notice that we've got the same factor, in the end, we'll wind up using that same factor when we write out our 2 final factors. So when we write out our 2 final factors, one of the factors is going to be that same factor. The other factor is going to come from the two GCFs. So we're going to take those two GCFs, the x and the -6, and it's going to look like x minus 6. We're going to take those two GCFs and we're going to write that as one of the factors. And then the other factor is going to be that same factor. All right, so again, when we write out that final factor, one factor using the GCFs is x minus 6. And the other factor using that same factor that we had after factoring out the GCF is 3x plus 4. Guys, remember that this is still an equation. It is still equal to 0. And we need to solve this equation. So we still need to use the zero product property. And in other words, we need to set each factor here equal to 0 and then solve. It looks like this: x minus 6 equals 0 and 3x plus 4 equals 0. All right, and so when we solve each of those equations, we add 6 for this equation on the left side to both sides. We add 6. That's going to be x equals 6 as one of the solutions or one of the answers. And so when we subtract 4 from both sides on this equation on the right side, subtract 4 from both sides, that winds up leaving us with 3x equals -4. And then if we divide by 3 on both sides, we're left with a fraction or a decimal, however you want to look at it. We're left with -4/3. So these are your two answers, and that's pretty much it. So I do hope that this video has helped you guys and has given you quite a few different examples of what it looks like when you are solving by factoring, solving quadratics by factoring. And again, there was a lot of different methods that were involved in these. Factoring out GCFs. There was factoring difference of squares. There was factoring by grouping. And yeah, so again, all of this math is building on itself. So let's make sure that we've got those other previous concepts learned. That's all, folks. Hope this has been helpful to you.